We have Jerry, who's a master's student, and they're going to tell us about how to handle uncertainty at compile time. They need this mic, yeah.
Good afternoon. We are here today.
You have to turn it on.
Good afternoon. We are here today to convince you to embrace uncertainty in mobile app programming. You might be wondering why two people are presenting one paper.
That's because our advisor was uncertain about who should present it, so he's like, okay, go and present it.
So, Jerry, you are a mobile app developer, so what are you currently implementing?
Okay, what I'm planning to do right now is to create a game that is pretty graphically intensive and deploy it on the App Store so that, make some bucks along the way.
So, have you considered the energy consumption in your game? I mean, you don't want people to run out of battery when they play your game within 20 minutes, right?
Yeah, you're right. Yes, so I'm just planning to, throw in a bunch of if-else statements and, yep, should handle it fine.
So let's speak about this if-else statement. So are you going to have one threshold for all users?
Currently thinking of setting the threshold to like 10% battery level, but I'm just not too sure.
So this is the threshold. I mean, it could be low, very low for a set of people, right? Maybe, for example, for me, low battery means 30%, but for you it would mean 10%. So how are you going to be sure about that?
Yeah, I don't know how I handle it using if-else.
So what about the branches? Do you even know if these branches work?
Yeah, if the condition isn't right, then
I mean, let's assume that it works. How well would it work?
Lost. I just don't have an answer.
My answer to Jerry is embrace uncertainty. So today, programming languages enforce programmers to be certain about each and every line of their code. So let's take an example. For example, if-else statement. The programmer has to be certain about the condition of the if statement, and also for the branches, each branch will not be executed unless the condition would be true. So what we are proposing is maybe statement. So as you can see, maybe has no condition, and each branch is dealt with as an alternative that could be selected by the app whenever it sees that this is the best alternative available at the current time. Maybe statement can be represented in various ways. For example, multiple blocks that have different alternatives. Each block has one alternative, and there is a label that helps the system to identify the statement in the code. It also can be used with variable assignments. For example, here we have string performance that could take one of these three values: low, medium, and high. And also, maybe presents a new feature, that is a range shortcut for integers. For example, I don't need to enumerate each and every number within a range. I just write 1 to 16. So maybe statement can be used by programmers to express uncertainty. And maybe system uses testing and learning to convert that uncertainty to runtime certainty. So, as a result, our major goal in this system is to know the best alternative at runtime.
All right, so let's get to the magic behind the scenes here. So we have a piece of code here. that is written in this way. So the presenter is Ali, or the presenter could be Jerry. So the old people prefer Ali to present to them, whereas the young people prefer Jerry, that's me, to present to them. So how does the app know about all of these things? Well, we'll come to that later. But this is a form of static adaptation in which one option is chosen, and yep, that's remained steady for a long period of time. Similarly, from India, Ali is chosen to give in a presentation. From Kuwait, Jerry is chosen. And coming to like dynamic adaptations, what if an app wants to behave differently during times in which it's not actually used much during the night, and it wants to behave differently during the daytime? So all these are temporal adaptations, examples of temporal adaptations, and network-based adaptations as well. For example, Ali prefers to use cellular data, whereas I prefer to use Wi-Fi. So how it works is like this. The maybe system, right, has adaptation algorithms embedded into itself, and this adaptation algorithm chooses which block to execute. So I'll talk about the adaptation algorithm later. But this, suppose if the app developer doesn't want to be, he doesn't want to give this form of control to the system itself. He or she could, just override this methodology. So our advisor, so he could control, like, okay, Ali should give it the talk, or Jerry should give the talk, but as of now, he's confused and he's sitting in the back there, like, okay, you guys handle it. So, moving on to like maybe testing. So this is how the adaptive algorithm works. Initially, the system needs to be tested, and then the system needs to be adapted for the use cases. So let's talk about testing phase first. We have a bunch of users, and we execute a block, maybe the maybe block or the or block on the set of users, and we calculate the scores. And these, okay, and also another block is executed on the same set of users, and the scores are calculated. Now, this is where in which the testing is done and the scores are actually evaluated. And what happens is, given a bunch of users again, we apply randomly which block of code should be executed on them, and we compute these two scores again. So all of these scores are keeping track at the backend server. So the backend server, yes, so the backend server applies some form of machine learning algorithm so that it could classify, like, for this particular set of users, this is the best alternative that could be executed. All right, so the scores. Talking about the scores, what exactly is the scores we are talking about? This course is computed based upon the performance and the energy consumption of the app. These are the standard way of actually how we go about measuring the scores, but the app developer has total control over how to measure the scores as well. So he can write a service like a JSON string or something that does a total different computation of the scores. And these scores given to the backend, some form of analysis is done, and then pushed back to the app again. All right, so Ali will take over.
So maybe system has a lot of use cases. For example, based on our experience in our phone lab, which is, by the way, large scale smartphone platform testbed, we had implemented a phone lab data collection tool that collects log data from participant devices. And while implementing that tool, we had a lot of questions that we needed to be certain about at development time. For example, when and how often to upload data, how often to rotate logs on the device, how much data to cache on the smartphone. We needed to have an answer and be sure about our answer at development time. We also had to specify an end-to-end performance metrics. So we ended up by writing hundreds of boring code, while if we used maybe statement, we had ended up just like by maybe tens of, or just line or two of codes by specifying the available alternatives without worrying about being sure which one we should really specify at development time and leave that for the runtime.
So another app that we have on the participants of Phone Lab is called Pocket Parker. So what this app basically does is to recommend a user where exactly a parking spot is available in one of the parking lots at the University of Buffalo. So in order to have this set of computations, right, we had to actually get the geographical location information of the user, like whether the user is riding a vehicle or whether the user is just walking from her car back to the building or something of that sort. So, okay, this app-specific information, we wrote a bunch of code. And also Google produced its set of code, like library APIs, after we actually implemented this code. So what actually ended up happening is we had two alternatives, whether to use our code or whether to use the Google APIs. So how do we actually know which one is better for our needs? So we ended up putting this into the maybe or block, and what we are currently testing the scores which are written from these alternatives. And on the long run, we'll get to know which alternatives are better for our needs. So fine. So these were some of our use cases at the Phone Lab. But when we look into the Android framework and the kernel, there are many places in which uncertainty could be mined upon. For example, the timer rails, the timeouts as well. When should the network search be timed out? When should the Wi-Fi search be timed out? If the app is deployed in US, should it search for 5 minutes? And if the app is deployed in an Asian country, should it search for a longer time or should it search for a lesser time? Cache sizes. This is another important thing. We are not so sure about cache sizes during compilation time, but during runtime, it's pretty important. And other things like performance quality trade-offs and attempts at battery level adaptation, as what kind of discussion me and Ali had at the very beginning of the talk. And we are also open to any suggestions, where do you think uncertainty needs to be measured in the kernel or the Android framework. So we want more feedback from the audience regarding that, maybe at the end of the talk.
So as of our current status with maybe system implementation, we are currently implementing a rewrite-based implementation for Android Java. And the maybe system consists of 4 core components. The first one is a preprocessor that rewrites the maybe statements or converts the maybe statements into current existing conditional statements. And we also have Android service to cache values and implement adaptation algorithms. There is also a backend server to drive testing, collect data, analyze data, and broadcast data. Broadcast the selected alternative. And we also have, this is a feature, I believe, we also have a web interface to allow programmers to control the process. So the programmer has the choice to select one of the alternatives at any time. So for example, maybe at development time, he has just 10 alternatives that he wasn't sure which one to select. But at runtime, he found out that one of the alternatives, as of the current conditions, is the best alternative to work with. So he can set it manually using the web interface. So to summarize, we can say that forced certainty is a problem, particularly for mobile systems. And maybe statement and system allow programmers to express and embrace uncertainty and activate testing and machine learning techniques. So please embrace uncertainty. Thank you, and we welcome any questions.